Connaissance,
recherche,
sciences,
des sciences mathématiques,
théorie,
physique,
philosophie,
conférence, archéologie,
environnement, nature.
Okay, this work is part of a more general project that we have in collaboration with the University of Barcelona and the University Marie Curie here in Paris and the University of Montpellier here in France on the morphometrics, evolution, and phylogeny of the genus Arvicola, which is a very important genus of rodents. Several analyses have been carried out in the last years to, first of all, to assess if landmark-based geometric morphometrics is able to distinguish subspecies of extant Arvicolas on the basis of its first lower molar morphology. First lower molar is the character, is what we use for systematics purposes to distinguish the animal, especially in the fossil populations. Moreover, we would like to see if it is possible to estimate the relative contribution of phylogeny, size, and lifestyle to the variation of this first lower molar shape. And last but not least, we would like to see if it's possible to use the enamel structure of the incisors of Arvicola to infer ecological preferences of fossil forms of this genus. So Arvicola nowadays is represented by three species. The first one is Arvicola amphibius, that was formerly called Arvicola terrestris, that has mainly an aquatic, semi-aquatic lifestyle and is represented by several subspecies in Western Europe. A second subspecies is Arvicola sherman that has been erected to a specific status very recently. And a third species is Arvicola sapidus that is whose distribution is limited now mainly to the Spanish Peninsula and that has mainly an aquatic lifestyle. So we try to use as many populations as we can that would be widespread along Western Europe. And first of all, we digitized 18 landmarks and 17 semi-landmarks along the external contour of first lower molars of these extant specimens in order to perform a relative warp analysis and have a matrix that we could use later on for our analysis. On the basis of wear stages, we excluded seniles and juvenile specimens from the analysis because the morphology of the first lower molar is different from the adult ones. And then, in order to assess the contribution of lifestyle, of phylogeny, and of size to the variation of shape in molars, we use the method that has been developed by Burkhardt and Legendre and then developed again by Desdevies et al. In 1993 to assess the contribution of several explanatory variables to this dependent variable that we assume is shape. And first of all, we considered phylogeny. Phylogeny has been extrapolated by the literature and the knowledge that we have by literature on Arvicola, mainly by the paper of Taberlet et al. And by Pierney et al. On the basis of these two seminal works, we built a tree where we were able to estimate, and only estimate because sometimes we don't have ages for some of the populations, a phylogenetic tree from which we could extract a matrix that could be used in the variation partitioning analysis. As far as lifestyle is concerned, we know that, as we said before, that Arvicola Sherman has mainly a fossorial lifestyle, while Arvicola amphibius is mainly an aquatic, semi-aquatic animal. So we used a dichotomic variable, aquatic versus fossorial, to be used in the variation partitioning analysis. And we extrapolated size, we extrapolated size from the relative warp analysis that we performed on the first lower molars. So we could analyze the contribution to shape variation from all these three variables. And first of all, we see that as far as the shape of the first lower molars, and here's a relative warp 1 as compared to relative warp 2, the shape of the first lower molar changes, and relative warp analysis is able somehow to detect what are the more archaic and the first detached populations. Arvicola mosbacensis is the fossil form, and we can see here that Arvicola italicus and Arvicola musignani are grouped together on the very far side of this scatter plot. So the result of the variation partitioning shows that phylogeny is the main factor that contributes to the differentiation of shape, is either when we take it as a pure factor and also when we take it as a melanged factor with the rest. So we still have, though, a part of unexplained variation. So a variation that we were not able to explain with using all these three factors. So what we thought is we used lifestyle as a dichotomous variable. But what if we are somehow able to have numbers, to have something that helps us to define better what's the lifestyle of these animals? So we know fossorial versus semi-aquatic. But we also know that rodents mainly use incisors to dig into soil. Even when incisors are not the primary digging tool, they still use incisors to help the digging process. So we thought that maybe some modification could occur in the structure of the incisors when these incisors are used in the digging process. So let's briefly digress on enamel structure of the incisors. Already in the 19th centuries, it was observed that rodents' incisors have two layers of enamel. These two layers have been called an internal portion and an external portion. The external portion is mainly composed by radial enamel. You can see it here when it runs parallel to the outer edge, while the internal layer is composed by lamellar enamel, which is composed by almost X strata, so strata that runs diagonally on one side and the underneath layer goes on the other diagonal. So Buza, Stevens, and Dahlquist observed that in the fossorial geomites, rodents, the thickness of the external layer, here the radial layer, is different in different genera of these rodents. And it changes accordingly to the thickness, to the kind of soils this fossorial animal are digging. So the outer layer of radial enamel is thinner in sandy, for animals that lives in sandy soils, and it's thicker for animal that lives mainly in harder and rocky soils. Another paper that studied ctenomites, rodents that are not specifically fossorial animals, show that the thickness of the outer portion, of the radial portion, is much larger in fossorial animal as compared to other ctenomites that are mainly arboreal. So we thought that maybe we could see if these results could apply also to our Arvicolas. And so we analyzed a subset of specimens as compared to the 11 populations that we used in the previous analysis, because enamel microstructure analysis is a destructive process, so we couldn't have access to all the populations we used before. So what we see is that in aquatic and amphibious, arviculo-amphibious populations, the outer radial layer, as compared to the lamellar one, is very thin, while in fossorial species, in the Sherman populations, this layer is very, very thick, as we can see also from the table here. A regression analysis shows that these results are significant also from a statistical point of view. So we performed again a relative warp analysis on this subset of population, because we didn't have all the 11 populations we used before. And again, we performed the variation partitioning analysis to see if the results are somehow better than before. So what we see is that phylogeny is again the main factor that drives the variation of the shape of first lower molars. But this time what we have is that anyway, the unexplained portion is still very high, but not as high as it was in the previous analysis. So maybe this is the way we should keep going. The third aim of this work was also to use the enamel structure to see if it could be used as a proxy to infer the lifestyle of fossil populations of Arvicola. Arvicola is often used in paleontology as a reference for biochronological papers, for biochronological inferences, but is also used as an ecological standpoint, because we've always thought Arvicola is a semi-aquatic genus. So if we find Arvicola in our fossil faunas, that means that the environment is humid, that there are ponds, or anyway water is close and present. But this is not exactly true, because we've seen that Arvicola sherman is a mainly fossorial species, so we cannot extrapolate this as easily. So we analyzed some specimens of Arvicola mosbackensis from the Middle Pleistocene of Mosbach, around 500,000 years. And then we analyzed some Arvicola sp from the Bouziers site from the late Pleistocene of France, and also some specimens from the late Pleistocene of Italy. And you can see it also from the pictures here. We have a very thick radial enamel layer. as compared to the lamellar one. While here we have an intermediate situation. So when we compare the results for fossil forms to the results that we obtained for the extant populations, we can see that Arvicola mosbacensis has an intermediate value, while the Bouzier specimens show a very, very high enamel index. The enamel index is the relationship, the ratio between the outer external layer as compared to the total thickness of the enamel, while the Arvicola italicus from Grotta Breuil has a very, very low index. And when we compare it to the values that we obtained, again, graphically, we can infer a fossorial lifestyle for the French specimens, definitely a semi-aquatic lifestyle for the Italian specimens, and probably an aquatic lifestyle for the Middle Pleistocene Arvicola from Mosbach. So, in conclusion, we have seen that landmark-based geometric morphometrics is a good tool to detect morphological differences between those subspecies that differentiated before, as the Italicus, Musignani populations. And also, we have seen, using landmark-based geometric morphometrics and variation partitioning, that phylogeny is the main factor that controls teeth morphology. Still, we have a quite large unexplained portion of variation that might be due to diet, to vegetation, to some factors that we are not able to assess. Most importantly, we have noticed that the enamel index, with the enamel structure of the incisor, is a valid proxy to assess lifestyle, being directly correlated with the fossorial degree of the specimens. And that helped us to extrapolate these results to fossil forms. This way, a probable aquatic lifestyle from the Middle Pleistocene Arvicola mosbacensis can be inferred, as well as an aquatic lifestyle for the Italian populations, and a fossorial lifestyle for the Arvicola sp from Bouzier. That is also supported by observations that have been made on cranial features. So that's it. Thank you. I would like to thank the Natural History Museum and a lot of people that loaned us with no return the specimens that we used for the SEM analysis. Thank you.